Power angle curve is a curve between electrical power output and load angle delta, where load angle delta is an angle between induced EMF E and terminal voltage V. Suppose load current I lags voltage by phi. I-axis is drawn perpendicular to I. Phasor addition of V and I-axis is done to obtain induced EMF E. Construction lines are drawn. Angle ACB is equals to 90 minus phi. Angle FCD equals to 90 minus phi. Thus angle CFD is equals to phi. FD is equal to I-axis cos phi is equals to E sin delta. That is I cos phi is equals to E sin delta by XS. Power per phase is equal to VI cos phi. Substituting I cos phi with E sin delta by XS, we get power per phase is equal to V E sin delta by XS. Or power per three phase is equal to 3 EV sin delta by XS. Power is maximum at load angle 90 degree. Thus maximum power is equal to 3 EV sin 90 by XS is equals to 3 EV by XS. Using P is equals to 3 EV sin delta by XS, electrical power output versus load angle curve is drawn. When load angle is between 180 and 360 degree, power is negative. It means that the generator is consuming power. It has become a synchronous motor. When we say load angle between 180 and 360 degree or between minus 180 and 0 degree, both are same and both pertains to synchronous motor. Since our topic is power angle curve of synchronous generator, power angle curve of generator is drawn. Stability means ability to return back to steady state after disturbance. Let us examine the left side of curve, that is load angle between 0 and 90 degree for stability. Let Pm is a mechanical power input and load angle is delta naught. At steady state, electrical power output Pe is equals to mechanical power input Pm. Angular velocity of rotor omega r and angular velocity of stator omega s are equal. Suppose, due to certain reason, electrical power output Pe is increased suddenly. Since mechanical system has a large time constant, it cannot change immediately. Hence Pe becomes greater than Pm. There is a deceleration and omega r becomes less than omega s. Load angle delta decreases and Pe becomes equals to Pm. But omega r is still less than omega s. Thus load angle keeps on decreasing. Since now Pe has become less than Pm, there is acceleration and omega r starts increasing. Load angle keeps on decreasing till omega r becomes equal to omega s. Rotor oscillates a few more times and settles at delta naught. Thus, generator has come to steady state after load increases suddenly. Now let us examine when electrical power output Pe decreases suddenly. Pe becomes less than Pm omega r becomes more than omega s. Load angle delta increases and Pm becomes equals to Pe. But omega r is still greater than omega s. Load angle keeps on increasing. As the load angle becomes more than delta naught, Pe becomes more than Pm. Rotor decelerates. Omega r decreases till omega r becomes equal to omega s. Rotor oscillates a few more times and settles at delta naught. Since the generator has come to steady state after disturbance, the load angle is between 0 and 90 degree. This region is stable. Now let us examine the right side of the power angle curve for stability. Suppose electrical power output PE increases suddenly. PE becomes greater than PM. There is deceleration and omega R becomes less than omega S. Load angle delta keeps on decreasing and will never return back to delta 1. Let electrical output power PE decreases suddenly. PE becomes less than PM. There is acceleration. Omega R becomes more than omega S. Load angle keeps on increasing and the generator will never return back to delta 1. Thus at load angle delta 1, load angle does not come back to original position after disturbance, and hence the region between 90 and 180 degree is unstable. Power is maximum at load angle 90 degree. As load angle becomes more than 90 degree, generator becomes unstable. Hence load angle 90 degree is called steady state stability limit. The steady state stability limit is the maximum flow of power without causing the loss of stability. Stability margin is the difference between maximum power and steady state power. Recommended load angle is 20 to 30 degree to take care of transients. Transient means a large increase in load for a very short time.